Hi again. Now let's move now to circuits that they are really um, more complicated, or maybe let's say more they need more like analysis. And here what we are going to do is we are going to use new rules, and these rules are really called Kirchhoff's rules. Okay, and then we are going to try to find out something about, how we are going to deal with these situations, what are really the rules that we are going to use, and how we are going to deal, okay, with these. Just bear with me. Um, we call them rules or um, laws, or whatever. Okay, then now here I will say we can sometimes we can reduce the electric circuit so that it can be series, parallel, combination. But sometimes we might have more loops, and like the network is going to be maybe more difficult to analyze, like maybe the following. Like here I have a battery here, and its internal resistance R1, and this is EMF1, and then we have here another EMF, and this is the internal resistance of it. Therefore, this situation is not going to be analyzed easily. And maybe I have a resistor here. Then this is really multiple, I would say, loops. Okay. Now, I will say here, I need maybe to make some of like kind of here definitions. The first one, it is a loop. What is the loop? The loop, it is a closed path. Then if I am going, okay, let me use the red. If I'm going this way, all the way this way, all the way here, this is one loop. Okay, then this I can say that the red is loop one. I can say also that if I will go from here to here, okay, here to here to here to here, this is the green, it is loop 2. Also, I have another loop here, which I might give it like a blue, then it can be this loop here again. Okay, then this is loop 3. Okay, then this is really, okay, very important to understand that what is really the definition of a loop, which is, I would say, a closed path of the circuit. Also, I need to define a junction, and a junction, it is a point where three or more conductors intersect or meet. Okay, then this is really here. This is a junction here. This one is not, this one is not. Okay, and of course also This one here, it's a junction. Now, okay, now Kirchhoff's rules, the first one has to do with junctions. Then, okay, we're gonna say Kirchhoff's junction rule. It says that the sum of the currents into the junction should equal 0, which means here you can say I have maybe bunch of currents, all of them, they should be added to 0. Then I might say I1 plus I2 plus I3, whatever, like, in my case, maybe they are really 3. And what is really the meaning here is that if I have a junction here and I have, this is current I2 and this is current I1, they're gonna go through this one, which is I1 plus I2, which I can call it maybe I3. Okay, then this is really something that we need to know. Now, also, we have Kirchhoff's loop function, loop rule. Which is a closed path. Remember I said the changes in the voltage or the potential difference should equal 0. Then the sum here, I'm gonna write the sum of the potential differences around any loop should equal 0. This is a statement that verify that electrostatic force is conservative. Now, also related to this, and like we want to see how really to use these, there are sign conventions that we should follow for the loop rule. Now, when we apply, now if we are traveling, okay, we're gonna like travel through the circuit. If we will travel in this in the circuit from negative to positive, this is the EMF, then I will say that this is gonna be considered positive EMF. If I'm gonna travel in the EMF and this is again negative positive, if my travel is gonna be in that direction, then that is gonna be negative EMF. And I'm gonna show you how we will really apply these rules. Now, okay, a travel here means the direction that we imagine going around the loop. And we're gonna, like, when we're gonna apply, we're gonna say, okay, we are going to go in the direction of the clockwise or the counterclockwise, and this is what we are going to apply. Now, what about when I have a resistor? When I have a resistor, it has to do with the direction of the current. Now, if this is a resistor where you have this green is gonna be the direction of the current, okay, then this should be negative, this should be positive. And if I am, okay, this is the direction of travel, I am traveling against the current. Then here I will say I'm gonna have the potential difference plus IR. Now, if I have that resistor again, and this is negative, this is positive, and the green is the current. Okay, the green is the current, but I am traveling in the opposite direction, which is this one here. This is the travel there, okay? Then here I'm gonna write for the potential difference negative IR. Now I will say here what are really the rules that we are going to follow in solving these problems. What I will do is, the first thing, I'm gonna first, okay, the steps. First, label your circuit as A, B, C, D, whatever, like you wanna, And then number 2, choose your loops. Number 3, show the direction of all the currents. Then travel in a certain direction, either clockwise or clockwise. And it should be a closed path. Number 5, apply junction rule. Then apply loop rule. And then the last step is gonna be calculate the unknowns. And I will show you in the coming video. I hope that I'm gonna do 2 examples here. Okay, thank you.